Hello and welcome to this vodcast about pH. The aim of this vodcast is to explore the meaning of the term pH in more detail and to learn how to calculate pH values from hydrogen ion concentrations. So you should already be familiar with the pH scale ranging from 0 to 14, but what does it really mean? Well, pH is a measure of the hydrogen ion concentration in solution. If you look at the scale here, you can see that low acidic pHs have a high concentration of hydrogen ions, whereas high alkaline pHs have lower concentrations of hydrogen ions. So Coca-Cola has relatively more hydrogen ions than hydroxide ions, whereas oven cleaner has fewer hydrogen ions than hydroxide ions. Notice that at pH 7 the number of hydrogen and hydroxide ions is the same. The hydrogen ion concentration correspond to the pH value is shown here on the left. So a pH of 14 has a hydrogen ion concentration of 1 times 10 to the minus 14, and a pH of 13 has a concentration of 1 times 10 to the minus 13. So each point on the pH scale represents a tenfold difference in the hydrogen ion concentration. This is an example of a log scale. This means that large changes in the concentration can be represented by a smaller, more convenient value on the pH scale. Once we know this relationship, we can work out the pH of any solution if we know the hydrogen ion concentration as shown by this equation. The square brackets refer to the concentration of the hydrogen ions, so by taking the log of this value and changing the sign, hence the negative sign, we can calculate the pH value. What is the pH of these two hydrogen ion concentrations shown here? You may be able to work it out without using your calculator for these simple examples, but make sure you know how to do it on your calculator for more difficult ones. Pause the video while you have a go. So the first one is pH 3 and the second is pH 10. Note the relationship between the power that the 10 is raised to in each case. Conversely, we can work out the hydrogen ion concentration for a given pH using the opposite relationship. Now 10 is raised to the power of the negative pH, so you'll need to use the inverse function on your calculator to do this. Can you work out the hydrogen ion concentration for these two examples? Pause the video while you have a go. So the first one is 1 times 10 to the minus 4, and the second is 1 times 10 to the minus 9. Again, these could have been worked out without using a calculator, but make sure you know how to do it, because the following examples are not so obvious. So pause the video here and try and work out the answers to these ones. Here are the correct answers to the first part. How did you get on? And these are the answers to the second part. If you're still unsure how to do this, try watching this video cast again. Thanks very much for watching.